This video is about capacity planning. The basic definition of capacity is it is the upper limit or ceiling on the load that an operating unit can handle. So, which means the maximum a facility or operations they can handle it. And by capacity, we mean that it also includes equipment, space, and employee skills, because all these things together they are involved in making a product or delivering a service. Therefore, we say whenever we talk about capacity, equipment, space, and employee skills, they are included. And the goal of capacity is the reason we study is that because we want to match demand with supply. Now, just imagine a situation. You want to buy something and uh, that thing is out of stock. So, what impression it will give you? Of course, you won't be happy. There are two terms that we'll be using in this chapter. One is overcapacity and other is undercapacity. Overcapacity means that an organization or a firm has capacity more than needed, which mean let's say they might have more employees or more machines or more space, and this is something which of course is adding cost. If you have more employees and more machines, they are adding more cost and they are reducing your competitiveness. So as a result of that overcapacity, although you may be able to serve all customers because you have slack resources, but your operating cost will be too high. And the opposite of overcapacity is undercapacity. When resources are strained and you don't have much resources, and therefore there is a possible loss of customer. There are two terms or two types of capacity. One thing is called as design capacity and other one is effective capacity. Design capacity, the definition is that the maximum output rate or service capacity an operation, process, or facility is designed for. So this is essentially theoretical. And effective capacity is that design capacity minus allowances such as personal time and maintenance. In every organization, there will be some contingencies. Maybe sometime system is down, sometime maintenance is going on, or sometime some employee is absent. So when you subtract all those allowances from design capacity, that becomes effective capacity. Now I will explain this with an analogy. Consider your car. In your car, you have an odometer, and uh, think what is the maximum speed mentioned on the odometer of your car? It might be something maybe 140 or maybe more than that. A regular car, I'm not talking about some sports car, a regular car may have a maximum speed of up to 140 or something close to 150. But now ask yourself how many times you have reached that speed limit that's up to 140 or 130. How many times this has happened in the past year? Maybe your answer is no, I have never gone to that speed limit. So in that case, in this analogy, I want to explain that 140 miles per hour speed is design capacity, which means under a theoretical condition, a car can go up to that speed. But normally you won't. And normally even it may not be possible because, for instance, when you are actually driving, there will be air resistance, there will be friction, and those people who are sitting in the car, their weight, and many other factors. I mean, just imagine for a moment that even if the speed limit, that factor is muted, then still many other factors, they will prevent a car from going to maximum speed, that's 140 or 150 or 160. So this is the whole idea of our design capacity and effective capacity. So we say that design capacity is the maximum output rate for which a capacity has been designed. So it is essentially theoretical, which means it is not realistic to achieve design capacity. However, when we subtract these allowances, then we get this effective capacity. And these are some formulas that we'll be using very frequently. So one thing is the actual output, which means the number of units, the number of service, and that an organization is producing. That's called actual output rate. And then next thing is efficiency. Efficiency is the ratio of actual output and effective capacity. And then another term is utilization. Utilization is the ratio of actual output and design capacity. Now, just imagine, for instance, a car wash, like a tunnel car wash. So just imagine how these three terms they would apply there. So actual output would be essentially something that number of customers who visit there and they get this service. So that will be actual output. Then there is something that's called utilization, and utilization, which means actual output divided by design capacity. So maybe you can say that possibly a car wash has been designed to serve or to wash 20 cars per hour. It was designed with that purpose. But in reality, when you take away different type of allowances, as we discussed earlier, then maybe it can only serve a maximum of 15 cars. And that will be, we can say, effective capacity. And then actual output is that depending upon how many customers visit there. So for instance, you can say maybe only 8 customers or 10 customers. So these are three terms. Again, utilization would be a ratio of actual output and design capacity. Efficiency is the ratio of actual output and effective capacity. And again, effective capacity is design capacity minus allowances. I mean, for instance, just imagine when you go for a car wash, uh, a tunnel car wash, then many times there are people, they are guiding you through that. And sometimes they have to uh, ask you that, okay, put your car in neutral and don't put it in drive mode. And then they're asking you that move on the left side or on the right side. So these are constraints, which mean from the design capacity, which means, let's say, for instance, that tunnel wash, it was designed with that perspective in mind that it will be serving 20 cars per hour. But actually, when they are guiding you, and sometimes some customers they understand those requirements, sometimes they don't understand, and they may require more time. So when we accommodate, when we include those type of allowances, then effective capacity would be much less. For instance, let's call it 15. Here's an example. Let's say in at a trucking station, design capacity is 50 trucks per day. So that's theoretical, which means it's ideal. It cannot be achieved. Pretty much like 140 miles per hour speed on your car, you never reach that speed. So that's design. It's theoretical. It's ideal. And then effective capacity is 40 trucks per day, which means once we take away some allowances from design capacity, that's called as effective capacity. And then actual output is 36 per day. So you see that how it is decreasing. Design capacity is highest, 50, and then effective capacity is less than design capacity, and actual output is further less than effective capacity. So this is essentially the order that would be there. Design capacity would be highest, followed by effective capacity, and actual output would be the lowest. Now, let's say if we calculate efficiency and the formula for efficiency, it is the same formula that you will be using in solving problems. Efficiency is the ratio of output, actual output divided by effective capacity. So actual output here is 36 and effective capacity is 40, is 36 over 40. And if you multiply by 100, it will give 90%. Similarly, when we talk about utilization, utilization is actual output divided by design capacity. Actual output is 30 and design capacity is 50, 36 over 50. And if you solve it and multiply by 100 so that we can express it as a percentage, utilization will be 72%. So you can see here that utilization is lower and efficiency is higher, and the reason is also very clear because in utilization we are using design capacity in denominator, and design capacity is always highest. Therefore, when denominator is high, then you get lower answer. But in the case of efficiency, we are using effective capacity. Effective capacity is lower, is less than design capacity, and when denominator is small, then you get a higher value. So that's called efficiency. So efficiency is 90% and utilization is 72%. Now, why is this important and what are its implications? And the implications are that, for example, some stockholders or owners of an organization, when they design something, of course, they make investment and they consider this utilization. But when we talk about managers who are actually running that organization, they will be considering efficiency. So what owners or principal or stockholders of an organization, what they are expecting, they might be expecting, they would say, okay, this is our design capacity and therefore utilization is only 72%. But a manager might say that efficiency is 90%. Now, what are the determinants of effective capacity? These are some factors that affect the effective capacity. One thing is facilities, and by facilities we mean the size of facility. Is it a large premises, small premises? Is there provision for expansion? Can it be expanded in future or not? Where is location? Because of course people have to travel daily to that facility. Transportation cost, heating, lighting, and layout of work. So all these things, they will determine facilities. They will determine a capacity related decisions. Now, I would like to give you an example here. Let's say you go to McDonald's or any organization or any fast food chain. You all these fast food chains, they have been very scientifically designed. And maybe if you can recall, there is a movie, a very good movie. I think its name is, it's about McDonald's. The name of the movie is The Founder, if I recall correctly. It's about McDonald's. So that's about how McDonald's, it was designed in the beginning. There were two brothers and they were trying to design everything on a very scientific basis. They were trying to do simulation. They were drawing on the ground using chalk, and then they were doing simulation. Okay, if I pass on this tray to you, how long it will take, and if that person passes on to another one. So they were doing this type of simulation. So these fast food chains are very scientifically designed, which means the layout of workplace. So that's what facilities. And the next thing is product and service factor. In general, um, product design and complexity and opportunities for standardization, they also affect capacity. So if a product is relatively simple, if it does not require many components, then capacity would be higher, because if processes are simple and straightforward, they can be standardized. But on the other hand, if the product is complex, it requires multiple components which need to be assembled, then for that capacity would be low. So I would say that standardization or opportunity for standardization is an important factor. And as you can see, that in any fast food chain, they always strive for standardization. So the burger you want, they will standardize it, which means they know that all the burgers that are made, they will have a specified amount of all these ingredients, and it's just like machines making all these things. Then process factor, output quality, and multiple products produced in a batch. So how is the process? Is process simple or process complex? And what type of quality expectations are there? If there are high quality expectations, then of course it means capacity would be low, because you will need extra steps. You might need more inspection. You need more systems. Then human factor, like skills of employee training, experience, and fatigue. So all these factors, they contribute to skills. So for instance, let's say if people are very much skilled, they are trained, they have experience, they are not tired, so then capacity would be high. But on the other hand, if people, employees, they lack skill, they are not trained, they don't have sufficient experience, or they are working overtime and they have fatigue, then capacity would be low, because they would be making mistakes. And as a result of that, effective product, the rate of production of right product, that would be low, and capacity would be low. Then policy factors, which mean, for instance, does organization allow overtime and number of shifts? So these are something where regulatory uh, uh, factors come in, and for instance, how much overtime is allowed, because overtime is something for which you have to pay a premium price. You cannot pay someone at the same rate for overtime. So if someone is being paid at the rate of $15 per hour, overtime rate should be higher than 15, a premium rate, and then number of shifts, etc. And then operational factor, that's inventory and late deliveries and quality inspection procedures. So if these operational factors, and for example, you don't have inventory, or inventory related factors, which mean your processes are dependent on inventory received from supplier, and you are dependent on supplier to receive inventory, and there's a possibility that there might be late deliveries, which mean you may have to stop your operations, and then maybe you have to do inspection. Once you receive some supplies from supplier, then you have to do inspection before you actually use them. So all these factors, they will reduce capacity. The next factor is supply chain. For example, about supplier and a warehouse capacity, where your suppliers are located. Are they located somewhere in China, in Asia, South America? And what about warehouse capacity? Or there might be some disruption in supply chain disruption. There might be some hurricane that might affect logistics, and all these factors. So supply chain factors, they would affect capacity. And by affecting capacity, which means they would, in general, reduce capacity if there are any problems in supply chains. And then there are external factors like product standard, uh, pollution standard and paperwork requirement. So for instance, if a country is very strict on pollution about emission, greenhouse gas emissions and wastewater emission, in that case, that country, for instance, that is the case of the United States. United States has very strict standard regarding pollution. So which means you cannot release your water discharge from a factory into river or into ocean, and you have to recycle that water. Similarly, how much smoke, greenhouse gases, and carbon emissions, they also need to be in control. And as a result of that, when you take into consideration these factors, then your capacity would decrease. But on the other hand, in some country, for instance, in China, pollution related standards are lenient. They are not as tough as in European Union or in the United States. So therefore, organizations may not bother about pollution, and they will continue doing their job. They will continue doing their production without taking care of pollution. So in that case, their capacity would be higher, although it will come at a cost of pollution. So you see that these are some factors that affect capacity, and in many cases, there are trade-off. If you improve capacity, there might be another trade-off. And if you compromise on that, then maybe your capacity could increase. Another term that we will be using in quantitative problem solving is called as bottleneck. So for instance, let's say an operation in a sequence of operations whose capacity is lower than that of the other operations. Now, for instance, let's say this is an organization and there are different operations, operation 1, 2, 3, and 4. And each operation is producing at the rate of 10 units per hour. 10 per hour, operation 2 is also 10 per hour, operation 3 also 10 per hour, and operation 4 also 10 per hour. So the total will be 40 units per hour will be produced. Now, these units from operation 1 to operation 4, their combined output is 40. But the thing is that at the following unit, the capacity is only 30 per hour, which means although the preceding one, they are producing 40 units per hour, but the following process can only handle 30 per hour. So which means that's a bottleneck. Now, in this case, managers, they might need to do something different. So for instance, they may need to address this bottleneck. They need to work on increasing the capacity of this one, which means they need to increase capacity to at least 40. Or if they cannot increase capacity to 40 for some reason, they believe that we don't have resources or it is not technically possible, then they need to shift some resources from preceding units to this point. Or maybe they can set up another unit in parallel to that, whereby some of resources they will go to other process. Now, when we talk about capacity, there are two terms that we very frequently used, and one of them is called economies of scale, and the other is diseconomies of scale. So the idea of economies of scale is that, for instance, let's say here's a graph, and on this graph, on x-axis, we have output, which means how much a factory is producing, and on the y-axis, it is cost, how much it costs to produce. So initially, let's say, for instance, when you are at this point, which means your output rate is low, you are not producing much, focus on the movement of this cursor. So at this point, when your output rate is low, you see your cost is very high at this point. But as you increase your output and you move on the right side, then your cost is also decreasing up to a point. And this is called as economies of scale, this part. So, which means that when you have enough capacity or resources, and if you are producing low, your output rate is low, then your cost will be high. But if you increase your output rate, then your cost will go down. This is called as economies of scale up to this point. So this point, nadir point, the lowest point, we call it optimal output rate. Because when you go beyond that rate, and which means if you are further producing more, your output rate, you are further increasing, then a point will come then when your cost will start increasing soon again, and it might go high, and it will make a U-shaped curve. And that point would be called as diseconomies of scale. Now, here you see economies of scale. If output rate is less than the optimal level, then increasing the output rate results in decreasing average per unit cost. And then diseconomies of scale is on the other side. So here, for this one, let's say if I say this is the center point, on the left of the center point, which means this one, that would be economies of scale. And on the right side of the center point, if you keep increasing output rate, and if it increases up to that level, that would be diseconomies of scale. So diseconomies of scale will be on the right side, right to the center. And the definition of diseconomies of scale is that if the output rate is much more than the optimal level, and where is the optimal level? Let's say we say this is optimal level. So which means if you're producing more than the optimal level, then it will increase, uh, it, it will make the processes suboptimal. Increasing the output rate results in increasing average per unit cost. Okay, now let me give you an example. Let's say, for instance, again, I will give you an example of a fast food chain. Consider that there are three people working at fast food chain, let's say at McDonald's or Burger King, and they have a reasonable number of customers who visit them, and they are doing it. And manager realizes that it is taking too long to serve customer. And what's the reason? The reason is that because we have only three employees, or maybe we have limited number of machines. So what is the first thing that he would do to serve customers better? Because if they are able to serve their customer better, that would increase revenue opportunities. So the first thing that would come to their mind is that, okay, inject more resources into the system. Okay, let's hire more people. Right now we have three people. Let's make them six, and let's have one more machines for dispensing a soda dispenser, coffee, etc. Okay, now when they go from three to six, of course, and that would increase their processing speed. They would be able to serve more customers, right? So initially, three employees, they were serving less customer. But now when they have six employees, they are able to serve more customer. And as a result of that, processing time also goes down. So they are able to serve customers better, and that increases their revenue. So that's called as economies of scale. Now, let's say another situation is that suppose the manager does not stop at six employees, but rather they hire four more people, because they think, okay, initially there were three employees, and when we increased them to six, that was very good, and our processes were streamlined. Okay, let's further increase to 10. Now, that is something where a problem can come. Now, six people were okay, that were fine. But once you have 10 people working in the kitchen, what would happen? They would be running into each other. They'll be bumping and hitting into each other. They will be occupying more space. No, which means they will be obstructing each other. In addition to that, your cost is also increasing because you have gone from 6 to 10 employees, and with 3 people or with 6 people, you need less supervision. But if you have 10 employees, then maybe you need a formal system, a human resource system, a system to control employees, to monitor employees. So all these things, they will be increasing your cost. And then soon the manager would realize that having 10 employees has significantly increased their cost, and it did not increase productivity uh, beyond a certain level. This is called as diseconomies of scale, that point. When you go from 6 to 10, and of course all these numbers are just theoretical, that's only meant for demonstration, only to explain. This is further explanation of economies of scale. If output rate is less than the optimal level, so again, we can talk about this one. If the output rate, this is output rate, is less than optimal level because it's on this side, then if you further increase, then your cost is going to decrease. If the output rate is less than the optimal level, which means the level at the center, and if you increase your output rate, you keep producing more, then it results in decreasing average per unit cost. And you know that that line is falling down, so which means that cost is coming down. And again, the reason for economies of scale is that fixed costs are spread over large number of units. Now, here's an example. Just imagine you have uh, some ball pens with you. Now, there is a fixed cost. Fixed cost is the cost that's associated. That's the a cost which mean to set up cost. Or more specifically, I would say fixed cost. For example, when you buy some machines and you set up the whole infrastructure, that cost is called as fixed cost. Let's say, for instance, you have capability to make ball pens, and you can sell them. And making that ball pens, it requires a machine. Let's say that machine cost $1,000, and you are able to get that machine, buy that machine for $1,000. You put it in your garage and you start producing ball pens. Now, imagine what would happen. Just imagine um, the fixed cost is 1,000 because the machine that you bought, and that's for 1,000. And then there are some variable cost, which mean for instance, a ball pen is made of plastic. And for plastic, there are plastic granules that are melted. And you also need some ink. You need that small ball um, that rolls the pen, and some packaging material. So that's called as variable cost. Okay, now just imagine if you produce only one ball pen, then what would be the ball pen of that cost? Of course, if you have to include those fixed cost and all those variable cost, then its cost will be, the cost of one ball pen would be more than $1,000. And who is going to buy that? Okay, now imagine that rather than producing one, no, you produce 2,000 ball pens. Now, in this case, $1,000, that's a fixed cost, that is going to be distributed over 2,000 ball pens. Now, which means each ball pen will be able to take 50 cents of the fixed cost. So let's say all those 2000 ball pens, they take up 50 cents of the fixed cost. And let's say um, the variable cost is 25 cent. So 50 plus 25 cents, that's 75 cents. Now the cost of one ball pen is 75 cents. So you see, when you were producing only one ball pen, then the fixed cost, it had to be included in the price of the ball pen, which means the price of one ball pen was more than $1,000. But when you are producing 2000 ball pens, then the price goes significantly down, and it's something only 75 cents. So you see that when you are producing more quantity, the cost, the fixed cost, which is actually very high, $1,000, it is distributed over 2000 ball pens. So this is the point. Construction cost increase at decreasing rate as facility size increases, because you just have to do a little bit expansion rather than building the whole unit from the scratch. Processing cost decreases due to standardization. And when you are producing something in bulk, then there are opportunities for standardization. And when there is standardization, then your productivity increases. And when your productivity increases, your capacity would increase. Because standardization is that you don't have to worry about individual units. All units are produced in the same way. So that's called standardization. Okay, now let's talk about diseconomies of scale. Now, which mean we are talking on the right side of that point. If the output rate is more than the optimal level, increasing the output rate results in increasing average per unit cost. So let's again going back to this one. No, we are at this point, and if you further increase your output rate, then a time will come when your cost, it will start increasing, and it will follow this pattern. Note the movement of the cursor. So this will be the pattern. It will be going up. And the reason is that because distribution cost increase due to traffic congestion when you are producing too much, and shipping from a centralized facility rather than multiple smaller facilities. Now you are producing too much. Your output rate is very, very high. As a result of that, it will affect your operations and your systems. Complexity increases cost, inflexibility can be issue, and additional level of bureaucracy can come. As I was mentioning, that I was giving example that, for instance, at a McDonald's, you have 3 employees. Moving from 3 to 6, it could be okay. But increasing from 6 to 10, which means now you need to have a formal system of managing employees, their attendance, or their performance tracking, their payroll, their salaries. All these things, they should come from a system. And as a result of that, when you are investing in those type of systems, then bureaucracy increases. Now, in this slide, we are comparing different plant size. So it's a small plant, and then a medium plant, and a large plant. And as you can see, let's say this is the nadir point, the lowest point where the cost is lowest. So it is this one. For a medium plant, this is the nadir point. That's optimal level. And for a large plant, this is the nadir point, the optimal. And as you can see that when we are increasing output rate, you can see that large plants, they become more efficient and more cost effective. The cost is lowest. So this axis, y-axis represents cost, and with the large plant, the cost is lowest. For medium, cost is high, and for small, cost is even higher. So this is the whole idea, why those organizations that have very high capacity, which mean they are producing in bulk, they tend to be more efficient and more productive. On the other hand, those that are operating at the smaller level, their cost would be higher and they may not be that much competitive. Now, how do we make these decisions about capacity? So, for instance, how do we determine that if there is something we should buy from a supplier, or we should do it in-house, or we should outsource it? So one of the factors called as cost volume analysis. This is the one that we'll be using in problems. And then financial analysis, which means we just compare numbers. We see, okay, if this option, this alternative cost us this much, what is the cost of other alternative? And then decision theory and waiting line analysis and simulation. These are the techniques that we'll be discussing later in this chapter. So one of the technique that we'll be doing in almost all of those problems is cost volume analysis. But before we go to cost volume analysis, I want to tell you that some of the terms, the first term is fixed cost. So in operations, this fixed cost, as the name mentions, that this is the cost that remains fixed. So let's say you are a manager in an organization, and these type of costs, they would remain fixed. For example, let's say you buy a machine. So that is a fixed cost. Or let's say if you are paying salaries to people. Now, salaries to people, you have to pay them every month. That's not going to change. You cannot increase or decrease salaries of people every month. So that would be a fixed cost. Similarly, if you are renting a building, then it means you have to pay rents, lease, again, which means this is something you have to pay every month, and that's not going to increase or decrease. So that will again be an example of fixed cost. So remember, fixed cost is the cost that remains the same. And when I say remains the same, it means it does not vary by the number of units you are producing. It will remain constant, it will remain fixed, and that's why we call it fixed cost. Again, recapitulating, the example of fixed cost is that you buy some machine, and that could be an example of fixed cost. Or if you are paying salaries of people, you have to pay them. It doesn't matter if a customer visit or a customer does not visit, your sale is low, your sale is high, you have to pay your employees. So their salaries could be an example of fixed cost. Similarly, lease, you have to pay the rent. Irrespective of what is your sale, sale is high or low, doesn't matter, you have to pay the lease. So that's why these are called as fixed cost. And the next thing is called as variable cost. So variable cost is the cost that varies by the number of units you produce. For instance, you are running a coffee shop. In a coffee shop, there are some type of cost that will change depending upon how much you are selling. So for instance, if you are selling coffee, um, if there are more customer, more coffee will be used, more plastic cups would be used, and more napkins would be used, more content, sugar cream would be used, a creamer would be used. So all these things, if there are more customer, these ingredients, they will be used more. So which means your variable cost would be high. But on the other hand, if there are less customer, then you are using less coffee because less coffee is being sold. So you are using less coffee, you are using less number of plastic or paper cups, you are using less stirrers, straws, sugar, cream, and all these ingredients. So these type of cost, they are called as variable cost because they vary based on upon your sale or the number of customer. If there are more customer, you are selling more, you will be using more ingredients, variable cost would be high. But on the other hand, If there are less number of customer, sale is less, you are using less ingredients, and therefore variable cost would be low. So variable cost, you see, it will keep changing depending upon the number of customers or your sale. So that's why we call it variable cost. So because variable cost, it depends upon the number of units. So therefore, whenever we write variable cost, we always multiply it by the quantity. So this is a rule, because again, variable cost, it depends upon how many customers you are serving. So therefore, variable cost is quantity, which means the number of customers or the number of coffee cups you sell, and multiplied by cost per unit. That will be variable cost. And when we add fixed cost and variable cost together, that gives us total cost. So total cost is equal to fixed cost and variable cost. And remember, variable cost will always be multiplied by quantity. Then next thing is revenue. Revenue, as you know, it's very intuitive, which means when you sell something, uh, um, then there's a price. For example, the price of a cup of coffee, and when you multiply that by number of customers served, that will become revenue. So revenue, which mean total revenue is equal to revenue per unit, which mean you can say price. Let's say the cup of coffee is $2, suppose, and there were 100 customers. So your revenue will be 2 multiplied by 100 will be $200 revenue. This is the last slide, and in this slide, I will be explaining some of the relationship between revenues and a cost, and how we convert them into an equation. So the key concept here is break-even point. So break-even point is the quantity at which your cost and your revenues, they are equal. Now consider something. Your revenue is something that's coming into your pocket, and cost is something that's going out of your pocket. So revenue you like, cost you don't like. Although you don't like cost, but they are essentially needed in order to serve customers. So when uh, the your revenue is equal to your cost, then it means you are not earning any profit. So your profit is zero, and that point is called as break-even point. So the number of units or the quantity at which revenue and your cost, they are equal, uh, that is called as break-even point. Let me explain this further again with the example of coffee. You are running a coffee shop, and of course, you have already invested a lot in machines, in employees, lease, rent, etc. All these things. So these are cost. And let's say there are only a few customers, which mean you won't be able to recover your revenue. So which means you are going in a loss. But as there are more and more customers, then accordingly they are bringing more revenue, and a time would come when revenues from customer and total cost, they become equal. So at that point, when your cost and revenues, they become equal, which means at that point your profit is zero, and that point is called as break-even point. So break-even point is the one where your profit is zero, or in other word, a break-even point is the one which means the quantity you are selling. Even if you are making ball pens in your garage, you are selling cups of coffee. So that number of cups of coffee or number of ball pens, that is called as break-even point. When your cost, and again, what does mean by cost? Cost mean like fixed cost plus variable cost together. That's equal to revenue. That's called as break-even. And again, break-even point is the one where your profit is equal to zero because you are not earning anything. And what's the equation for profit? The equation for profit is equal to revenue minus cost. And again, by cost, we mean fixed and variable cost together. And when we talk about variable cost must be multiplied by quantity. So if I put them in a mathematical equation or a model, it would be like profit is equal to revenue from 1 unit multiplied by number of units you are selling. So this is something total revenue, R times X. This is revenue that's coming into your pocket. And when you subtract your cost from this one, this in parentheses is the cost, which means fixed cost plus variable cost multiplied by number of units you are selling. So that is variable cost and fixed cost together, that's total cost. So we say that profit is equal to your revenue and minus total cost. And at break-even point, it will be equal to 0. And if you further solve it, it will become R times X becomes RX. And then this is negative. And when minus, this is distributive property. When you open it, here, when you open this one, this negative is distributed. And when you open this parenthesis, it becomes Rx minus fixed cost and then minus variable cost. So this positive sign is converted into negative. This is the distributive property you have studied at high school. So when these parentheses, they are opened, then we get this one Rx minus fixed cost and minus multiplied by plus, it becomes negative is equal to 0. And then when we further solve it, and how do we solve it? You can say, for instance, let's say add here plus FC fixed cost and also add here plus fixed cost, and they will be cancelled. And when you do it, then you will be getting this equation for break even. And from here, you can take X as a common factor, and that becomes R minus V. R is revenue, V is variable cost. And then you get this formula for break-even point, which means that break-even point is equal to fixed cost divided by revenue minus variable cost per unit.